Yesterday we did 14. Let's do 13 today. Who's going to talk about it?
He said I could do it.
Okay, come over. So you will sing the song, I will follow you. 13 1 ja 13. Likewise you will start.
13
1 ja 13. 13 2 ja
26.
13 3 ja
39.
13 4 ja
52.
13 5 ja
65.
13 6 ja
78.
13 7 ja
91.
13 9 8 ja
104.
13 9 ja
117.
13 10 ja 130.
150.
Okay. So the way Advik was saying, that is how it has to be, and everybody has to say exactly the same. So when you are saying 13 3 ja, you will not stay muted till he says 13 3 ja. You will also say 13 3 ja 39. So that way, that gets not stuck in your brain. So 13 3 ja is always 39. You don't have to wait for somebody to say 13 3 ja. Okay. All right. Thank you, Advik. Let's start with our class then. Okay. So something interesting. Okay. Tasvik is a baby for me, right?
8 years old.
Yeah.
I'm also.
You are also a baby. He's a much smaller baby, right? So yesterday when I recorded his video, I could not see him in the video actually because this is not in the right position actually. I will buy a stand and then put it in a way that everybody can see you guys going forward. Okay.
You just kick him off.
I don't mind doing it. You guys are like kids for me always, right? So yeah, I mean I might not be able to pick up Bhupal, but yeah, everybody else I can. Huh? Myra went for a
Concert.
she had a recital for her sister, so she went to attend that. Okay, anyways, so let's start. So today we are going to talk about exponents and powers. So exponents.
They eat a penny mouse.
And powers.
Really powers of powers also do PEMDAS. My dad just taught this today.
So
No, he didn't.
okay, so whatever it is, it might be a surprise, it might be a good thing, it might be a bad thing. So wait till I finish the concept and then hold your questions till that time. Okay. So if you give me 5 minutes, I'll explain something. Then if you have any related question, then you can ask. Okay. I know kids at your age, you have a lot of questions, you have a lot of curiosity. So I'll be able to answer most of it, but allow me to finish some of the concepts and then let's see if there's something that is to be explained. Okay? Okay. Now, let's look at something like this. What is this? It's a variable. We don't know what is the value of a.
3 to the power 8.
8 to the power 3. Meaning?
A times A times
Yeah?
A times, it's A cubed.
Okay, so a to the power 3, a cube, whatever you call it, okay? So this is what. If somebody says x squared, what is that? X into x, right?
Just like 3 X's in a row.
Yep.
Okay,
It is. Wait, no crosstalks in between, okay? So this part is clear, right? Anything to the power that means that number is multiplied by itself that many times. Okay? So if I tell you guys 10 to the power 4, what is that? 10 into 10 into 10 into 10. 4 times.
200.
4 times. Yeah?
200.
Huh?
200.
No.
Wait, no, not
10,000.
10,000.
10,000.
Yeah.
Yeah.
Okay. So let's not see it. I'm probably one of the unique teachers who doesn't really care about the answer. I don't really care about the answer. What I care about is the concept and the approach. Okay? If you know the approach, if you know the concept, you can do thousands of sums related to that. If you focus on getting answer for one question, you are limited to that question. Okay? So we are all here to learn the concept so that we can do hundreds, thousands of sums related to that concept with ease. Okay? Ease meaning with comfort, in an easy way. Ease means something that is done with in an easy way. Okay? Now let's beat this concept to death. Okay? Now somebody says 4 to the power 3. 4 into 4 into 4. Clear? Somebody says 5 to the power 2. 5 into 5. Are you guys noticing something here? Let's say if I put this also. 4 into 4 into 3. Okay? When I say 4 to the power, or let's say, when I say 2 to the power 1, what does it mean?
2. It's just 2 by itself.
It's just 2. Yeah? If I say 3 to the power 0,
Then 0. And it becomes 0 because you're sizing 0 by 3.
okay, so this is your learning for the day. When you say any number to the power 0,
It means nothing.
that is 1. Anything to the power 0 is 1.
How is it?
If I say 1 million, okay, to the power 0, okay,
It's 1.
it's 1. Any number,
I think
million, billion, gazillion, whatever you can think of. Trillion, yeah,
quadrillion,
exactly. Anything,
septillion,
anything, anything except 0.
a googolplex.
I don't know what is Googleplex, but whatever it is, that to the power 0 is 1. If that is not 0.
Septillion,
Yep, anything.
infinite.
And so,
Google.
anything. So, any number. Okay, okay. So, again, focus back. Focus back. Any number to the power 0 is 1. If that number is not 0, you will not say 0 to the power 0 is 1. This is wrong. Okay?
Because it's already 0.
0 to the power 0 will be 0 only. Okay? But any other number other than 0 to the power 0
It's 1.
is only one answer, that is 1. Okay? I will give you guys are doing very well. I'll give you 10 billion to the power
Can you make it 10 minutes? Or just
billion to the power 0. This many dollars.
One.
I'm only giving you $1. Okay?
Woo, but see, how is it becoming 1? Is it like you're dividing them?
No, it just
I know.
like 0 is 0, right? Likewise, if you say
It's not all
anything to the
zeros.
power 1, that means that number,
Itself.
right? That means that number. Anything to the power 1 is that number. Be it 1000 to the power 1 is 1000. 10,000 to the power 1 is 10,000. 10,000 to the power 2 is 10,000 into 10,000. But the time you put a 0, you get only 1. Okay? This is not going to change till I die. Okay? So this is a universal process. Okay? Any number to the power 0 is going to be 1. Right? Feed that, store that, save that, fix that. Okay? Okay, you have a question.
Are you gonna have homework about powers?
Let's learn first. I don't know how many of you have read Gita.
Oh, yeah.
Gita says just do your work. Don't think about the result always.
Wait, what's
Okay.
Gita? It's a book.
Gita is a holy book in Indian
We
mythology.
have it in a book.
Okay.
That
There is one. Okay, so let me not distract you guys, but yeah, what it says is do your work always. Do the right things always. Don't worry about the result. Okay. Whether you'll get a homework or not, we'll see.
Did they say that? Homework?
Huh?
Did they say matters or
They made a generic statement saying just do your work. Don't worry about the result always. Okay. So when you are doing your work, be honest and just do it. Okay. Alright. So coming back. Okay. So. Huh?
Wait, is time measure a part of like math or not?
Yes, we'll talk about that also. Time measurement, everything we'll talk about that in level 1. Okay. So let's start. Level 1 is from 3rd to 5th grade. So don't worry. Level 1 is not grade 1.
Our teacher says that we're going to learn exponents in our 6th grade with
Don't-
using PEMDAS.
So don't worry about that. I'm not going to tell you the same thing that you have been learning from your teachers. I'm teaching you something more. So that way, yes. So that way you will know. You might end up knowing a little more. Okay, that's fine. So now, whatever we have learned is this. anything to the power this means this number multiplied by the same number that many times. 4 to the power 3 means 4 is multiplied by 4 3 times. 4 to 4. Okay. Now every 4 is like 4 to the power 1.
Because it's one of the three.
Yes.
One of the three powers.
Right. So okay. Don't jump. Go slow. Okay. So this is clear, right? No doubt about this. Clear last week? Gopal, are you clear with this? Now, if I break this into two parts, 4 into 4 into 4.
So
This is also fine?
So we
No. It's only me teaching right now. Wait for it. I'm just trying to convey some concept here, okay? I'm just trying to derive some concept for you guys. So this is clear. We can say it like this, okay? So 4 to the power 3, we can always say as 4 to the power 2 into 4 to the power 1. Is this fine?
yeah.
Yeah? Are you with me last week, Gopal?
Yeah.
So here, what we can see is, actually when you are multiplying the same number with different powers, what happens is, this power actually gets added. So 4 to the power 3 is equal to 4 to the power 2 into 4 to the power 1. So this is, actually if you can write this as 4 to the power 2 plus 1. Or here in this case, you can write this as 4 to the power 1 plus 1 plus 1. See, because you are multiplying 4, so you are multiplying, so you are basically 1 plus 1 plus 1. Is this, are you able to digest this first? Making sense? So now I will get to the meat of this problem. So, if I say 2 to the power 2 into 2 to the power 8, what is the value of this guy? Okay, go ahead.
2 by the power of 10.
Okay, that is one answer. What is your answer? What is your answer? Is it wrong?
No, is it wrong?
No, you have to give your judgment. I don't want to blindly follow anybody.
2 to the power of 10.
How?
Because you add 2 and 8 plus 2.
Bhupal, do you agree? Is this correct?
I can agree with the first one more.
Huh?
Yeah, that one.
Yeah, 2 to the power 8 into 2 to the power 2 equals to 2 to the power 8 plus 2, meaning 2 to the power 10. Is this a fair thing?
It could work.
It could no, it has to work.
Yeah.
Because that is what we learned before, right? We said 4 into 4 into 4, meaning 4 to the power 1 into 4 to the power 1 into 4 to the power 1. Since the base was same, this is, in this kind of thing, this is called base and this is called exponent. That is the chapter, exponent of power. Okay?
Numerator and denominator.
No,
As in
this is not
fractions.
numerator denominator.
Yeah,
This is exponent. So this is the base and this is the power or exponent, whatever you call it. So the thumb rule is, when you are multiplying two numbers with the same base and different or same exponent or power,
Improper.
this gets the power gets added. So what that means is, tomorrow if somebody says you what is the value, how long you will take to do this?
Is that a G? Sir,
9, this is 2, this is 9, this is 16. There is no,
2 by the power of 27.
what to the power 27? 10 to the
10
power.
to the power of 27.
Now you guys know what I'm saying? So the base is the same. So what you will do is, if you are multiplying, you will just add the powers. And it is simple, because 4 into 4 into 4 into 4 is equals to 4 to the power 1 plus 1 plus 1 plus 1. 4 to the power 4. So same way here, the base is the same. You will just add the power. And this is mathematically possible. We are just using the shortcut here. So if you have to multiply a number like this, you can imagine how many pages you will need to do the calculation. Wherein if you know the concept, it's very easy. It's a simple classic example of an exponent. You're just looking at the base, adding the power, you do it in one sentence, less than a sentence actually. Yeah? So, now you will ask me, why do we really need to deal with this kind of unrealistic numbers? These are not unrealistic numbers. If somebody says, what is the distance between Earth and Sun?
14,000 miles.
No.
14,000?
14,000 miles? Then we can go in our car.
It'll be more than like.
I don't remember, but I think it is something like.
In the millions. Yeah, that. No, it's like more than that.
Probably more than that, okay? This many kilometers.
No miles.
And you will end up spending 2-3 minutes just to count the zeros actually. So, what you will do is, you will write this as 5 into 8 into 10 to the power, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is the distance between Earth and Sun. I mean, I'm not accurate. I'm saying this is of this magnitude.
This is 5.8.
No, I mean, don't remember this number. Okay, this is not correct. You can search in Google. It will tell you how many kilometers is the distance between Earth and Sun. It will be something which is like 10, 15 digit number. Okay. Okay. So what I'm trying to say is, exponents and powers are used for dealing with very large number or very small number. Now you'll say why and where very small number? Meaning, if somebody says this is the size of an amoeba, okay, and the let's say the length of the amoeba, this many centimeters. I mean, I'm just making it up, okay?
I'm gonna die if that happens for me.
Right? So I'm saying, when you're dealing with such a small number, see how many zeros are there, and there are numbers. Scientists use the numbers which are even smaller than this. That is why they use microscope or no,
Microscope.
or much powerful microscopes for seeing much smaller objects. Cells, electrons, protons, neutrons, whatnot. Yeah. So what I'm saying is, in simple terms, what we can say is, exponents are used for dealing with very large numbers or very small numbers in an easier way.
What about medium wave?
Medium wave is normal math.
Can I go
2000 into 5, everybody knows 1000, 10,000. Yeah?
maybe like 50?
No, I mean, even 50, see, anything natural numbers that we deal with every now and then, right? If somebody talks about my salary, this will be in few thousands, right? That's not a big number. If you're talking about the distance between Earth and Moon, or from Earth to, let's say, another galaxy, by putting the zero itself, you'll be lost. Yeah? So that is why exponents are used for dealing with or using calculation with huge numbers like this. Okay? Yeah, go ahead.
Can power work with decimal?
I'll come to that. So that's why I just gave you guys a clue that exponents are used for very large numbers or very small numbers. Now let's look at, we have looked at the large numbers. So somebody says, okay, just confirm this, okay, 4 to the power 8 into 4 to the power 26. What is the value?
4 by the power.
Tasvik, tell me, wait, I want to know if Tasvik is able to follow me or not. What is the value of this one? 4 to the power what?
34.
4 to the power 34, right? You don't really have to do, wait. Okay, so what I'm saying is, you don't have to struggle so much. You're just checking the base and adding the power. It's easy, right? 2 to the power 9 into 2 to the power 16. What is the value? Simple.
2 to the power 9 times 2 to the power what?
16.
Oh, no. Stop looking at me. What's 16 times 2?
No, 16 times 2, no. It's
What?
2 to the power 9. Wait. No comments. 2 to the power 9 into 2 to the power 16 will be how much?
25.
25.
2 to the power 25, right? Because we are just adding the powers, right? So 16 plus 9. Okay? So, see, I'll keep on asking questions to you guys just to make sure that everybody is paying attention, everybody is fully concentrated on the class. Okay? And the human brain is programmed to be distracted. Okay? So it's okay.
Programmed to be smarter than AI.
Let's not go there. I'll teach you guys. I will talk to you guys with AI when you guys grow up.
My dad is like addicted to AI. He's like buying a new AI device. He's getting
We'll talk about that. Okay. Let's focus on maths. Okay. So, what I'm trying to say is, when I'm asking questions, you guys somebody might be able to answer it right, somebody will not be able to answer it right. That's okay. It's my job to fix that. Okay. But nobody will pass on me comments because my job is to get everybody's attention. Okay. Now, so this part you guys know. So this much you have learned. Now let's say if I ask you guys to write, okay, let's do one more sum. 2 to the power 9 into 2 to the power 3 into 3 to the power 6. What will the value? Who will tell me? Okay, go ahead.
18.
2 to the power?
Sorry. It's 18.
Knowing the question is very important before giving the answer.
Wait. 6 to the power 12.
No.
No, wait.
Okay, wait. Let's see what Advik says.
This is like 2 by the power of 24.
I don't need that. So, don't do that, okay? See, I'm trying to simplify this. You guys are taking a very complex route. I will, see, if somebody says, you have 5 mangoes and give me 2 of them. And let's say you have bananas also. Will you give bananas instead of mangoes? No, you will not. So here are the mangoes, this is a banana. So I will say I can only do this guy. So 2 to the power 12 into 3 to the power 6. That's where I will keep it. That's what we have learned.
And that's it.
So that's fine. If somebody says give me the exact value, then we will see. But here, what we are learning as part of this one is this. Okay? We'll come to the laws and all, but okay.
Wait, I checked in my notes.
That's okay. So what I'm saying is, you will always, when you are multiplying exponents, you will always look at the base first, and only multiply or add or whatever you have to do with that. Okay. This is one part. Now, so what we learned is a to the power m into a to the power n is equals to a to the power m plus n. This is what we have learned so far. This is one of the laws of exponent.
Is that pi?
This is a.
Yeah.
Don't go. This is m. This is m. This is n.
Oh,
Okay.
I thought
Okay.
it was pi.
So okay. Focus back. Bhupan, put the feet down, please. So this is a formula. Okay. This is what we were doing. So if a is 2 and this is 3 and 4, then we are just using the formula. This is one of the laws that we learned. If you are multiplying two numbers which has the same base, the power gets added. This is what we learned. Right? Now let's look at other one. Let's say 10 to the power 3 divided by 10 to the power 2. What happens?
It becomes 10 by the power of 1.
It becomes 10 to the power 1 because it is like this. Or you will probably do it like this. I'm a very simple guy, right? So I will do it the simple way to get my concept.
Sometimes the simple way is my dad says, don't do this simple way, do steps and show me it.
Yeah, so that's what I'm doing. I'm just doing it simple way. This is my step, okay? So how Advik came to 10 is what I'm trying to derive here, okay? So this is what it is. So this can be cancelled. So this is left with 10. Now, what this means, let's do one more sum. 10 to the power 6 by 10 to the power 2. What happens here? 10 into 10 into 10 into 10 into 10 into 10. 6 times divided by 10 into 10. 1, 2. 1, 2. How many are left? 1, 2, 3, 4.
10
That
to the
is
power 4.
10 to the power 4. Now here, from this, what we can derive is, see, when we did 10 to the power 3 by 10 to the power 2, what happened? We got 10 to the power 1. So 3 minus 2, 1. Here, 6 and 2. It became 6 minus 2, 4. So this is the formula.
10,000.
Yeah, so this is the formula. What this formula is indicating is, if I do a to the power m divided by a to the power n, that is a to the power, whatever is the power of the numerator. Yeah. So now you look at both the formulas. A to the power m into a to the power n is equals to a to the power m plus n. So when you are multiplying, the power gets added. When you are dividing, the power gets subtracted. Is it related? Make sense?
Yeah.
So, if somebody gives, see, I showed you guys the two sums before deriving this formula in a very raw way, right? Now, if somebody says 10 to the power 25 into 10 to the power 16 divided by 10 to the power 9, what is the value? Tell me. What will you do? You know when you multiply what happens? You know when you divide what happens? So,
Got it.
what is that answer?
It's 10 to the power 32.
32?
Yeah.
25 plus 16 is that 41. Yep, yeah, you're right.
Let's go.
So what this means is, this is how I will do step by step now. Instead of writing 10, 25 times, this is what I will do because I learned the formula, right? So this is 10 to the power 41 divided by 10 to the power 9. Now I know when I divide what happens. It gets subtracted. Okay? Now I will show you guys one more magic. Magic or mathematical trick. I am not a magician, I am a mathematician. Okay? So, if I write 10 to the power 5, we know that the value of this is 10 into 10 into 10 into 10 into 10. If I say 10 to the power minus 5, what does it mean?
Negative 1 means that you're dividing.
You are dividing. That's what it is. So 10 to the power minus 5 means 1 divided by 10 to the power 5.
Wait, 10,
10 to the power 5 is 10 times 5 times 10. Okay, 5 to 5, sorry, 10 to 10, 5 times. 10 to the power minus 5 means you are dividing, as you rightly said. That means I am dividing 1 by this 10 to the power 5. So now look at this. Why it is minus 5? Okay. This is 1 here.
Why is
Okay.
that my paper?
Okay, wait. I'm proving the formula here. Okay. 10 to the power what? What happened? Everybody okay? Okay. All right. Just pay attention. Okay. Don't get distracted. Now, the other thing that we learned. Anything to the power 0 is 1. Okay.
Even infinite.
Wait, don't jump. Okay? Now, we also learned that anything to the power m divided by anything to the power n is equals to this minus this. Okay? So far, so good? Now, try fitting this value 10 to the power minus 5. Let's say A is 10. 10 to the power minus 5 means 10, 0 minus 5. Is this correct? Here. Can I say 10 to the power minus 5? Can I say 10 to the power minus 5 equals to 10 to the power 0 minus 5? Is this okay? No? Yeah.
Because it's not complicated.
No, it's not complicated. Okay, let me say this. What is a positive and what is a negative? Positive is what I earn, negative is what I owe. I have borrowed money from somebody.
No,
Okay?
not always.
Hmm?
Sometimes if you like you negative points, you mean
You have lost something.
taking
You have lost something. You have to recover, right? So okay, let's keep it simple. Let's not debate. What I'm saying is, let's relate positive and negative as profit and money that you have borrowed. Okay? Or let's say positive means money that you have earned. Negative is what you have borrowed from somebody. That means you have to give it to that person someday. Okay? Now here, minus 5 means you have not earned anything. You have just borrowed money. So you had 0 and you have borrowed something. Right? Let's say you made $2, okay? And you borrowed $10 from somebody. So this is your minus and this is your plus. What is your total balance? You will say 2 minus 10, meaning minus 8 is my balance. Right? That is okay? Are you with me so far? Tasvik, am I making sense here? Yeah? Okay. So, now just to keep it simple, anything minus, if I say minus 2, you can always write that as 0 minus 2. Nothing wrong with that. Minus 5, you can always write that as 0 minus 5. You have nothing, you are subtracting 5 from 0. That's how you have minus 5.
That's negative 5.
Yeah, negative 5.
What
So-
if you have 0 to the power 4 then?
0 power?
4.
0, anything to the power, 0 to power, whatever is 0 always.
Oh yeah. You know what minutes?
Okay?
It's like 0 times 0 times 0 times 0. It's not hard.
Wait. Let's come back to the concept. So, what I was saying was, 10 to the power, 10 to the power minus 5, I can write as 10 to the power 0 minus 5. Right? Now this fits with this formula. Right? Here m is 0, n is 5. So 10 to the power minus 5 equals 10 to the power 0 divided by 10 to the power 5. No, first tell me whether you understood this or not.
Yep. So basically saying 10. So 10, 10, 10, 10, 10, 10, 10. So you can,
No.
so you put 10 to the power 4.
No, there is no 4.
No,
It's
it's
only minus
literally
5.
0 minus 5, which is negative 5.
0 minus 5 is negative 5.
Oh yeah, if you swap it and it becomes negative, it becomes power 4.
No, it's not. I'm not swapping. I cannot. This is 10 to the power 0, which will be 1. Anything to the power 0 is always 1. Am I still with you guys? Are you guys with me still? Yeah.
What if the number has a power of the negative? What if the number of the power is a decimal? Then
So let's learn what we are trying to learn. We will learn more things. Let's get the simple concepts first, then we'll look at the complex ones. Okay? Let's first see. That's what I'm saying always. That you always focus on learning the concept and then you can play with the numbers actually. Concept will not change. Numbers could change. Okay? So let's focus on the concepts first. So what I'm saying is, anything to the power minus means 1 divided by positive of that power. That is what we proved here. 10 to the power minus 5 is equal to 10 to the power 0 minus 5. And this is another thing that we have learned. When you divide, the power gets subtracted. So here 10 to the power 0 by 10 to the power 5. That is 1 by 10 to the power 5. So in simple terms, whatever I have proved here, what you would end up applying is this. So anything to the power minus, let's say 2 equals 1 divided by same number to the power 2, positive of that. You have to just reverse it.
So it would be 10 times 10 by 1 and be 1 by 100.
Whatever it is, I don't really have to care much about it. If it's 10 to the power minus 15, it will be 1 by 10 to the power 15, that's all. So if somebody says 2 to the power minus 9, what is the value? 1 divided by 2 to the power 9. This is what you will remember, okay? Yeah? Minus 6, what is the value?
1 and then 3, 6.
3 to the power 6, positive. So this is like traveling, like a ping pong ball, right? So if you say 14 to the power minus 2, so what happens is, as soon as you see minus, that means your numerator is 1, and in the denominator you will have the same base, but the power changed from negative to positive. So this guy goes from here to here, and this becomes positive. That's it. Okay? If you move it that way, so let's say somebody says 1 by 12 to the power minus 14 equals what? Here, Advik, Tasvik, everybody. 1 by 12 to the power minus 14.
It's 12, 14.
12 to the power 14. Because as soon as you move it above, this sign changes from positive to minus.
Yeah, so it's like,
Negative
my dad told me like equal sign, like 2, like negative 2 equals positive 1. So if I swap it, 1 will be negative and 2 will be positive.
Mm-hmm. Yeah. So we'll talk about the operations again. We'll come to that. So this is so far we have learned 3 things. We have learned what is exponent, what is okay. We have learned exponent. We have learned negative powers. We have learned how when we multiply numbers with exponents, what happens? It gets added. When we divide, it gets subtracted. Okay. Now, and we learned about anything to the power 0 is 1. Right? These are the things that we have learned so far. Now, if somebody says, okay, let's look at the place values. Okay. So this is unit place. This is units place. This is tens place. This is hundreds place. This is thousand place. So on and so forth. So, or we should write it other way around. Okay, leave it. Let's look at this number, 1425. Can I write this as 1000 plus 4 into 100 plus 2 into 10 plus 5?
Yeah.
Yeah?
Technically,
Basically, I'm just breaking into units place actually. Okay. So this is in the thousands place. I have 1. So this is 1 into 1000. In the hundreds place. Yeah.
Technically expanded form plus.
This is the expanded form.
And what's it called? Notation form.
Yeah. So I'm explaining you guys the expanded form here. So this is, you can write this. This 1000 is what? 10 to the power 3. 4 into 100. 100 is 10 to the power 2. Plus 2 into 10 to the power 1. Plus 5 into 1. Meaning I can always write 1 as 10 to the power 0. So you can write any number in the expanded form like this. So whatever we have learned as exponents, I'm just writing a number in the expanded form as exponents of 10. is fine. So let's say,
Trash can.
I'm sorry,
Can I have a trash can? I can do it.
just keep it down. I'll pin it. Let's say somebody says, write 4928 in the expanded form.
That's 4,000 plus 9.
So it's always 4 into 1000 plus 9 into 100 because
That's.
plus 2 into 10
That's not expanded form. That's.
plus 8 into 1.
Notation. That's expanded notation.
Yeah. So whatever you call it, right?
You have to put parentheses on all of them.
You can put parentheses or you have to put parentheses, or if you don't put then also is fine because it's always the BODMAS rule that comes into play.
PEMDAS,
Yeah.
parentheses, exponents, division,
No,
multiplication.
but yeah.
Wait,
Okay.
wait, wait, wait. Does exponents come second in PEMDAS?
Let's focus on one thing. When we come to that, we'll talk about it. Okay. So you can always write this as 4 into 10 power 3 plus 9 into 10 power 2 plus 2 into 10 power 1 plus 8 into 10 power 0. This is expanded form, notation form, whatever you call it.
Expanded notation.
Yeah, or expanded notation. So this is another thing that is useful from an exponents or power point of view. Now there is one more formula I want you guys to, or one more law of exponents that I want you to learn. A to the power, let's say 2 to the power 2 power 3. What is that?
Technically, you're supposed to calculate the thing inside because it's like pen. So you do the parentheses first, so and then
Yeah.
inside the parentheses there's an exponent. So 2 times 2 is 4 by the power of 3.
See, right.
So
So-
it's going to be
64.
32.
So what I'm doing here is, I'm still doing this in a layman's term. As a nursery student. This is okay?
Yeah, that equals 2
No no rushing to the answer. I'm not interested in answer.
to the power 7.
This is okay so far?
Yeah, easy.
This is how you will break it? Like a kindergartner, if you have learned it?
No, I learned it in 1st grade.
Okay. So no, I'm saying as a junior student, this is okay. If anybody says anything to the power this in parentheses to the power this means this number is repeated that many times, right? If somebody says, let's say 2 to the power 4 times 3 or let's say 6, what that means is 2 to the power 4 into 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 2 to the power 4. Is this okay? This is how I will understand this. Now, look at this. Now, what is the value of this if I have to say this is power of 2?
Huh?
We learned that if I am multiplying this number with the same base, what happens? The power gets added. So this becomes 2 to the power 6. You had one option. You could have made you could have got the value of 2 square and then done it 3 times. What I did was I did not do the calculation. I just wrote it as is. And then I'm doing this. I got 2 to the power 6. That's big here. If I'm doing 2 to the power 4 into 6, what I'm doing is this. What is the value of this guy?
2 by the power of 24.
24.
That equals 2.
So here comes the new law that we are learning for exponents.
Newton's first law of derivation.
If anything to the power something, to the power something else, this, if I have to write this in the form of this, a to the power m to the power n equals a to the power m into n. Tell me this, m into n. Tell me this is falling through here. 2 to the power 2 to the power 3 came out to be 2 to the power 6. 2 to the power 4 to the power 6 came out to be 2 to the power 24, which is 4 into 6, 24. 2 into 3, 6.
So what does n equal? Oh, a equals to a, that equals to a m times n.
No, I'm just waiting for you guys to process this and tell me if this is,
Understandable, yeah.
yeah,
Uh-huh.
Tasvik? And you have to tell me, I mean, if I'm okay repeating this one more time. But tell me if this is, you have to understand this.
Yeah.
Not clear? Okay, I will repeat. No, so see, that is, you guys probably are much smarter than what I was when I was your age. Okay? So it was always like, my dad has to teach
What was
me.
your IQ?
Yeah, maybe I had a low IQ. My dad had to teach me something 3-4 times. And then I will keep on struggling. And then after 5th time, when I get a solid scolding, then everything starts going in quickly. So it depends. Everybody understands the same thing in a different way.
My dad
Okay.
always scolded me whenever done.
Okay, so now Tasvik, you will pay attention here, okay? I'm teaching this for you, okay? So, if I have 2 to the power 2, what is this 2 into 2, right? So far, it's okay? Okay. Now, if I say 2 to the power 2, 2 to the power 4, what does it mean? It means whatever I have inside the bracket, that is to be multiplied 4 times with itself. Correct? So this is 2 to the power 2 into 2 to the power 2 into 2 to the power 2 into 2 to the power 2. This part is okay? Now, you have learned that if I am multiplying this, what happens? It becomes 2 to the power 2 plus 2 plus 2 plus 2. Are you with me? Yeah? Because we learned, right? 2 into 2 into 2. 1, 1, 1. This became 2 to the power 3. So here we have power 2, 2, 2, 2. So we are multiplying. So the power gets added. So this becomes 2 to the power 2 plus 2 plus 2 plus 2 equals 2 to the power 8. Is it understand? Now, so this is what I was saying. So this law says if you have any number to the power m, to the power m, this becomes a to the power m into n. So here what happened? 2 to the power 2, inside the bracket to the power 4 became 2 to the power 2 into 4. 2 into 4, 8. Are you able to relate now? So that is why I did two sums, right? I said, okay, let's say 3 to the power 3, 8 to the power 2, meaning 3 to the power 3 into 3 to the power 3, because I have power 2, so this thing is repeating twice. Yeah? So this becomes 3 to the power 3 plus 3 equals 3 to the power 6. What is happening here? If you have the power inside the bracket, this gets multiplied by this. Yeah? So this is the law. So we learned 3 laws of exponents. Okay? First law is a to the power m into a to the power n equals a to the power m plus n. A to the power m or any number, right? A to the power n. If you are dividing, this gets subtracted. This becomes m minus n. Yeah? And the third law that we learned just now is a to the power m to the power n equals a to the power m into n. Yeah?
Yes, sir.
And other thing that we learned was, okay, we talked about the big numbers. Let's look at a small number quickly, okay? And then I will let you guys do some homework with that. So, let's say, what is the value of this in how I can represent this in fraction?
1/2.
Like I said,
It's a
I was a guy with the least IQ. So I never believed in myself. I always did things.
What is IQ stand for?
Intelligent quotient.
What's cosine? Question.
We will talk about it later. Okay?
Coefficient.
No, not coefficient. That's a different one. Okay, so I'll share that with you guys. Okay. Or you can ask your parents also. They can explain that. Alright, so now what I meant was I never believed or I never assumed, I never jumped. Never jumped, I just did things. So here I will convert this into fraction. I will not say 1 by 2 because I don't know how it becomes 1 by 2. What I knew was I can write this as this and I can knock off the decimal. So for every decimal I will bring a 1 in the denominator, and then how many numbers we have? 2 digits. So this is 50 by 100. That is how it becomes 1 by 2. Okay. So if I have a number like this, 3, 2, 3, 4, 3, 6, if I have to convert this to a fraction, what will I do? I will take out everything before 0, right? I mean, there is nothing here. There is no number here. It's only 0, right? So I will safely write 3, 4, 3, 6. All these 4 numbers. And then I will get a number 1 instead of this decimal. And then how many digits I have? 2 plus
0, 4.
4 zeros. Yeah? This is how I convert any decimal into a fraction.
What about percentage?
Percentage we have done in a separate class, but here let's focus on how these things are getting converted. Now, you know, this is what? What is this one? This is 10 to the power 4, right? So you can always write this number as 3436 by 10 to the power 4.
How would this just be extra one?
Yeah? And you can always write this as 3436 into 10 to the power minus 4. This also we learned. We took the from here to the numerator. So this is the decimal part. So basically, when I talked about the large numbers, we learned exponents. Exponents can be used for very small numbers also.
Questions.
Yeah? I can write this as, I will knock off all the zeros. I will just write 6 because there's only this number and everything else before that is 0. 6 divided by what? This decimal becomes 1. And then how many digits? 3 plus 3 plus 2, 8. 10 to the power 10 in 10. So this becomes 6 divided by 10 to the power 8, which is equal to 6 into 10 to the power minus 8. So I represented this small number in the form of an exponent. This is similar to what we have learned. I just touched upon this one. So this is where we bring it to the end of the class. So we have learned exponent. We have learned the basic 3 laws, right, of the exponent. And when you watch this video, you will be able to recall it. And then we learned how to represent a small number in the form of exponent, right? How do we convert a decimal into a fraction? And then how do we convert that into an exponent? Okay? I know it was a loaded class, but I believe you would have enjoyed it. I will give you guys some homework for this one. Do those homework, and then show it to your parents, get their signature. If some of the things are not clear, watch the video again, try doing it. If not, anyways, I'm here in the next class.